So here we have a time. Is it a time graph of velocity? Okay. The following diagram shows the velocity time graph of a car's journey from town R to town Q. The car accelerates for 2 minutes, travels at a constant maximum speed, and then slows to a stop. Cool. So we can see that here, right? With a velocity time graph, you always see speed or velocity on the y-axis and time on the x. And it normally represents acceleration. So here the vehicle is accelerating. Here it is going at a constant speed. The speed isn't changing. And here it is decelerating or decreasing speed. Um, I must mention though, if instead they bring a distance time graph, this means well, the vehicle is traveling at a constant speed. Here means the vehicle or the person has stopped, isn't going anywhere, they're stationary, and then they continue their journey. So that's the difference between whether it's velocity or um or distance time. Okay. So what they want us to do is to determine the initial acceleration of the car. To do that, we can use gradients of a line. The gradient will give us, right? So the gradient formula, what they want acceleration, so we put E. If it was a straight line graph, we put M. It depends on what they're really asking for, you know. So A as an acceleration is equal to Y2 is the same formula, but just in a different question. Minus Y1 divided by X2. Take away X1, okay. We need 2 points. So we can identify 2 points. I take in the beginning point, the start point, and the end. These should be easy ones. The start point is 0, 0. That's where before what was it? The car started journey. And then by the top there, the Y value is 30. The X value is what? Coming down here. It's halfway between 60 and 180. Huh? What is that? Like, if we take away 60 from 180, we get like 120. How about 120? How about 120 is not 60 again? But if we have 60 and 60 is 120. So that means here is like 120. So yeah, so here has to be about 120 because apparently the scale for this, it comes from 60 to 60 and it jumps to 180. So that means it's 60, add another 60 here, 120, add another 60, 180. Okay, yeah. So this is 120. So this other point, the x coordinate is, should I use a different color? You know, let me just start this all over. So 120 for x and 30 for y. Yeah, so this is going to be my x1, y1. I like to label the smaller values as x1 and y1 and the bigger values as x2 and y2. Okay, so we going to replace, now if you're wondering why and all, remember the y-axis represents speed, right? So these y values are given as speed. Y2 is 30, take away 0 for y1. And x2 is 120, and the x's represent time. Take away x1 is 0. When we take away these, that will leave us with 30 over 120. 10 into 33, 10 into 120 is 12, 3 into 3 is 1, 3 into 12 is 4. Okay, you don't want to write your answer as a quartile because it's a speed question we're doing here, but you could write it as a quartile, but the better thing to do A quarter, right? If you don't know what a quarter is in decimal, think about money. What is a quarter of a dollar? Not 25 cents. So you can write it as 0.25. That's another way to write a quarter. And it will be in meters per second squared because meters per second squared. But some people put it with ms to the negative 2. That's normally the unit you write acceleration in. Okay, so I hope you look at thus far. If you have questions, you know what to do. So that's the answer for here. The other one says calculate the distance. Distance, okay. The one the distance between the two tongues. Where are the tongues again? We said tongue R. Where's R though? The following diagram shows the velocity time graph of a car's journey from tongue R. So I believe tongue R has to be the beginning. The tongue Q, well, I guess that's the end because they didn't label anything. So yeah, it's a full diagram apparently. So in order to find distance on a velocity time graph, it is not as straightforward as a distance time graph, right? If it was a distance time graph, you just read it off on the y-axis. But when it's a velocity time graph, you have to find the area under the curve. The person, what? I know some of you who probably not too familiar is it. What? How you find the area under the curve? How do I give you distance? I'll explain that just now. But that's what we have to do, okay? So let me just take all these lines from here. Okay, we can use the trapezium. I think I go with trapezium now. Because if I look to divide this into two triangles and a rectangle, which I could, that is going to take, I was going to say 200 years, but it's not literally 200 years, but it's going to take up time that we don't have here, okay? So, but I'm still trying to show you, all right, with this, when you find in distance, you can divide, right, as this entire, this speed time graph here could be divided into two triangles. You'll see the two triangles there and a rectangle. And you find the area of each rectangle, well, one rectangle and the area of the two triangles. And you get it. But that is going to take up time. So the fastest way to do it is using the area of the trapezium. But again, before I do the area of the trapezium, I want to explain to those who don't know, why are we even going to find the area to find distance? Well, remember, you have to know what the formula for distance is, right? In order to find distance, you need to take the speed and multiply by time. The y-axis represents speed. It's right here. The x-axis represents time. So if it is you find in the area normally requires you take a length, multiply by breadth, and stuff like that. So then you will end up multiplying speed by time, because that's what you do when you use an area formula. Hence, finding the area of the trapezium or any other version, when I say version, I mean if you choose to do them in parts, you will be able to get the distance. So I'm using area of the trapezium, which is a half multiply by the sum of the two parallel sides AB by the height. Now, how do we figure out those things? So this entire diagram is a trapezium, right? Sometimes trapeziums can look slightly different, but that's what it looks like generally. The parallel sides are, this side is parallel to this side. How do we know they are parallel? Parallel sides, no matter how far you extend them, they never meet. No matter how far we extend these two, they're not going to intersect each other. If we extend the other two, they are not parallel. They will touch at a point. If we keep going up, they will touch at the top. at some moment or point. So the parallel sides are these two. So you label anyone as A or B. And you might be saying, why? Again, because we have to add A and B, so it don't matter which side in the parallel side to label as A or B. How do we figure out the length of these sides? Well, use the graph. Read the graph, and the graph will give you the length. Okay, read the axis I meant. I'm just taking this off, right? Because this might kind of, you know, mess up things in a way. Right. So to find the length, I'll start with the easiest side to figure out the length of, right? Um, use a different color. Come on, come on. So from here to here, right? That's where this line ends. Because this line is the same in the sense of it's horizontal, like the x-axis. Use the x-axis to figure it out. It starts from 0 on the x-axis. It ends at, if here's 780, we add 60 to that. What we get, like 8 and 6 is 14. 7 add 1 is 8. We get 840 seconds. That's time we deal with. So that means B is equal to this, 840. That's the length of B according to the time axis. And then, oh my, and then for A, according to the time axis as well, A starts from here, which I initially said was 120 before. And it ends there. That's the length of A, right? It ends at, if here's 540, 540 at 60, because it's another additional 60 will give us 600. So the length of A using the time axis or time is 600. So you measure the sides based on which axis they are parallel to or positioned in the same way as. To find the height could only be found between the two parallel lines. So you can find the height from here, from here, from there, from anywhere between here and there. Your person what? We mean there, miss. I don't get it. Anywhere between here and here, you can find the height. You can't find the height here. That's not the height. The height is only found between the two parallel lines. Okay? So if we just use from here to here, this starts from 0. That's where 0 is on the Y. And it ends at 30. So the length of that line based on the speed axis, the height is going to be 30. Okay, so let me 30. So using that information, going back to the formula, oh boy, boy. Yeah, I'm just going to write in the information and then I would I'll clear the screen from the unnecessary. So a half multiplied by A is 600. B is what was 840. And the height is 30. Yo, please make sure and use a calculator if you have big numbers like this because that, imagine working this out manually, it might take about 5 or more minutes just to multiply all them things. It's some big numbers we have. I'm going to use the calculator, but I have to reopen the calculator because I don't know where the calculator went. Just now, hold on. Let me open up Zoom calculator. Oh, I must mention, right? As of right now, normally class will end, right? But like I said, if anybody have to go, I understand, just let me know. But I want to try my best and see if I can finish this question. Well, not the question alone, finish the paper. So, we're taking a half But if you have to go, don't be afraid to tell me this. I got to go. I understand. Okay, so we have 600 plus 840. Uh, multiplied by 30. That's a massive number there. So we got that's the distance. That's a lot of distance. And it has a vehicle too, so it might as well do exactly that. What was okay, this will be in meters. It will be in meters because since this answer is in meters, that will be in meters too. So meters it is. Mm. So yeah, that's the end of question 8. We still have 9 and 10, you all. Let's go. If you have questions about this, feel free to ask me your question.